Hello class 9th. Today we will continue with Heron's formula. We have started with exercise 12.2. We have already done a few questions. Now we will take up question number 7th. Question number 7th of the exercise. What we have? A kite in the shape of a square with diagonal 32 centimeters and an isosceles triangle of base 8 centimeters and side 6 centimeters each is to be made of 3 different shades as shown in the figure. So you've been given the figure here. How much paper of each shade has been used in it? What I've done, I've already copied this figure in my notebook. As you can see here, I have a kite. The shape of the kite consists of 2 parts. Over here on the top is a square and the tail part is a triangle. In fact, this is an isosceles triangle for which the measurements of each side is given. The kite and the tail use papers of 3 different colors. So the first color has been used for this part. This is the first color. Then this represents your second color and the tail part is made of third color. You have to find out how much paper of each shade has been used. So what we want to find out, we want to find the area of these 3 different sections of the kite. Let's mark the vertices so that it's convenient to refer to the various parts. Let's take the point of intersection of the diagonals as O. So ABCD is square and triangle DEF is isosceles triangle. We want to find out area of triangle ABC. This is shade 1. Then area of triangle ADC. This is second shade. And then we want to find out area of triangle DEF. This is the third shade. If you look at the question, this has been marked as 1. This has been marked as number 2. And this has been marked as 3. So these are the 3 colors of paper which have been used. One color used for this portion, second color used for this portion, and the third color has been used for this portion. Now what we are given is the diagonal of square is 32 centimeters. For the square part, this is the only thing given to us. What do we know about the diagonals of a square? We know that diagonals of a square are equal. What else? Think. Last year you have done properties of quadrilaterals, so you are aware of the property for the diagonals of a square. The diagonals of a square are equal, and along with that, the diagonals bisect each other at right angles. So this property of diagonals of a square will be used to find out the area of the first and the second part. This means AC is equal to BD, diagonal AC is equal to diagonal BD, and each of these measures 32 centimeters. Since the diagonals intersect at O, this would mean that AO equals to OC equals to BO equals to OD. This will be equal to half of 32. Each of these diagonals are equal in length, and since both diagonals are bisected, means they are divided into 2 parts. So divided into 2 equal parts. So each of these parts of the diagonals, for diagonal AC, the 2 parts will be equal, AO and OC. For the diagonal BD, BO and OD will be equal. And each of these parts will be 16 centimeters. And further we have AC perpendicular to BD at point O. So that means we have right angle over here. Each of these is a right angle. Now if you want to find out the area of triangle ABC, I'll just draw a rough figure here. This is how my triangle ABC looks like. And from B there is a line segment going vertically downwards. I'm not considering that part. This is forming a right angle here at O. The length of the diagonal is 32 centimeters. This portion BO is 16 centimeters, and this is perpendicular to the side of the triangle. So this will be height and this will be base. To find out the area, I can directly use this formula, half base into height, to find out the area. So half into 32 into 16, this gives you 256 centimeters square as the area for triangle ABC. Similarly, if you take up the second triangle, shade 2, triangle ADC, which is on the opposite side of the diagonal, it looks like this. There is a line segment here connecting D and O. It is perpendicular. The length of the diagonal is 32 centimeters and the length of OD from here is 16 centimeters. So this is actually the same triangle like this one. Both triangles are identical. For this as well, the area for triangle ADC can also be calculated using half base into height. So half into 32 into 16, this will also be 256 centimeters square. Now you have area of the sheet used for triangle ABC, area of sheet used for triangle ADC. We need to find out the area of sheet used for DEF, which is an isosceles triangle. Now for this particular triangle, they are saying that the base is 8 and the sides are 6 centimeters each. So base is 8 means the unequal side is 8 centimeters and the equal sides are 6 centimeters each. For this, we will be using Heron's formula. So for Heron's formula, first of all, we find out the semi-perimeter. Semi-perimeter is given by sum of all sides divided by 2. So this will be 6 plus 6 plus 8 by 2. This will be 10 centimeters on calculation. Then area will be given by under the root S into S minus A into S minus B into S minus C. On simplification, you will find out that the answer comes out to be 8 under root 5 centimeters square. You could leave your answer here if you want, or you could calculate the value of under root 5, use it. This would be approximately 2.24 multiplied with 8. You will get the answer as 17.92 centimeter square.